Okay, in this video we're going to set up the states of matter unit. And I want you to kind of just take some assumptions with me, and these are things we'll actually learn more about in the chemistry unit. But for now we can just take them as assumptions. So, two molecules or atoms will attract each other. And the closer they are, the stronger the attraction. And that kind of makes sense, and that's very similar to gravity, in fact. And then we can say, well, if the molecules or atoms get really close, very close, they start to repel. And the closer they get, the stronger the repulsion. And the last thing is just saying, well, if they're really far apart, and I'm sorry for the vagueness there, the forces will be negligible. That means we can ignore them. It's like they're zero. And that's also true with gravity. And if you remember with gravity, if I had two planets and they were like really far apart, yes, they would still attract each other, but with so little force that we could ignore it. Same is true in this situation. So what I'm going to do is I'm going to draw a graph. And the graph is going to show R on the x-axis and F, force, on the y-axis. And R is really going to be the distance between two molecules or atoms. And we're just going to see how that the force changes as the molecules get closer and closer, right? As R decreases, we're saying that the force is going to change. And here can be our two molecules a distance r apart. So I mentioned in the previous slide that if they're really far apart, there's no attractive force, there's no repelling force, there's just kind of negligible. So this blue line is going to represent the force of the attractive force. See, it's kind of zero out here, it's really kind of too far apart. Then it starts to kind of get a little bit stronger as time goes on. As it gets closer and closer, it gets stronger and stronger. And this blue line is representing the attractive force. So blue line is going to be attractive force. And we'll draw a red line in here, which will represent the repulsive force. I said, well, when they're really far apart, doesn't really matter. And here's the difference between the attractive and repulsive forces. The repulsive force only really starts to pick up any steam when they get really close. But once it starts, it goes up really quickly. Okay? And now what I'm going to do is I'm going to draw a black line. And this black line, here, let me label this better. So we'll say that the red is the repulsive force. And the black will be the net force. Remember, net force is just saying, well, if I add up the attractive and repulsive, what will happen? And so if you just got these two lines and you kind of added their values together, you would get a line that would look like this. So they're kind of both zero out here. And then you'd eventually get it looking like this. I'm going to mark one place in particular. This point here, where the force is zero, we're going to call that distance r. That's going to be r equilibrium. That's going to be the equilibrium distance. And we'll talk about that in the next video. And you can see that at this point, at least on my graph, it's trying to say this. The repulsive force and the attractive force should be the same, and they're not exactly the same. But their attractive force is just strong enough to cancel out the repulsive force. And we'll talk about this more in the next video.